Hello, Advanced Algebra 2 students. Let's take a look at the first of two videos that you're going to have for this weekend on section 3.1 and 3.2. This is about linear equations and inequalities, the coordinate plane, distance, midpoint, slope. It should all be review. The videos should actually go relatively quickly, so I'm hoping you won't have to spend much time at all. Okay. Everyone knows about the coordinate plane. You saw that last year in geometry. The Cartesian coordinate system consists of a horizontal line, the x-axis, and a vertical line, the y-axis. The intersection of these two axes is called the origin. We know the ordered pair there is 0, 0. Then the xy axis divides the coordinate plane into 4 regions. And we call those regions quadrants. And they're numbered in a kind of a strange way. They start in the upper right-hand corner with quadrant 1, and then go counterclockwise with quadrant 2, quadrant 3, and quadrant 4. And so if you think about the values of x, y in each of these quadrants, the values of x, y in quadrant 1 will both be positive. In quadrant 2, the value on x will be negative, and on y it will be positive. In quadrant 3, they will both be negative, and in quadrant 4, the x will be positive and the y will be negative. And that will be important when we do breakpoints in the coordinate plane, that we think about how it traditionally looks, and we'll be able to use that in some of our problems to maybe take a few shortcuts. Okay, the distance formula and the midpoint formula. This is just review for everyone. You know how to use these. You've seen these before. The midpoint formula, x1 plus x2 over 2. So you're averaging those 2 points. The y value, y1 plus y2 divided by 2. Again, you're just finding the average of those 2 points. So I have an ordered pair. I have minus 5, 3 is where A is, and then B is at 3 minus 5 right here. So here's my line AB, and I'd like to find the midpoint of that line. So where is the midpoint? I can just use the formula. Minus 5 plus 3 over 2, and 3 minus 5 over 2 will give me minus 2 over 2 and minus 2 over 2. So my ordered pair for that would be at minus 1 will be the midpoint of that segment AB. And as I said, you've seen that before. That's not hard to calculate. The other one that I think you should have seen in geometry is you're given an end point and you're given the midpoint, and you have to find the other end point. So now we're told in this problem to find endpoint B of segment AB. So point A is at minus 4 minus 3, and that's A. Then the midpoint is at 3, 2. And so B is somewhere up here, because this is half of the line. A couple ways to look at this. I'm going to show you 3 different ways to think about this problem. One, you can look at the slope, and you can look at the vertical change from A to M. So this change is 1, 2, 3, 4, 5 units. So we can go to M and change that 5 units. Add 5 units there. And then we can look at the horizontal change. How does it change from A to M horizontally? So from A to M it changes horizontally 7 units. So then you go up to M and you change that 7 units. And that will give you your point B here at 10, 7. So that's one way to look at it. A really quick and easy way to think about it is to just put it on a line and say, this is my point A at -4, -3. My midpoint is at 3, 2. My point B will be where? So look at the change in x's. The change in x's is +7. So go to the midpoint, add 7, and that will give you the endpoint B, the x-coordinate of the endpoint B. Then go to the y-coordinate. Look how that changes. So this one changes by +5. Then add 5 to the y-coordinate of the midpoint, and you'll see that that puts you at 7. So one way is to use the slope. Another way is just to look at those points, see how they change. The other way will be the equation, and I'll show you that now. We know that x1 plus x2 divided by 2 gives us the midpoint of that x-coordinate, and that y1 plus y2 over 2 gives us the y-coordinate of the midpoint. So if I have an endpoint, A at -4, -3, and then I have the midpoint at 3, 2, I can substitute the values that I have into the equation and solve that. So my first x is going to be -4. I don't have x2, that's the other endpoint. I have the midpoint, which is 3. Multiply both sides by 2, and you will get -4 plus x is equal to 6. Add 4 to both sides, and you'll get x is equal to 10. Do the exact same thing for y. Substitute in the y value of -3 plus y over 2, y sub 2 over 2, and set that equal to the y value of the midpoint. Multiply both sides by 2, and you will get -3 plus y sub 2 is equal to 4. Add the 3, y sub 2 is equal to 7. Your ordered pair, 10, 7. So there are 3 ways to think about finding that other endpoint, using the slope and using the graph, using the change in x and the change in y from the endpoint to the midpoint, or the actual formula. Any of those will suffice in solving that problem. Distance formula, this is again a review. If you want to find the length of the line, segment AB, you're just going to substitute these values in to the distance formula. So x1 is -3, x2 is 7, and then y1 is 6. Minus -11 makes that a plus. This gives me the square root of -10 squared plus 17 squared. Remember, put that in parentheses so that you make that a positive. And then let's see what 17 squared is. $289. So AB is the square root of 389. So that was just a review. Now let's take a look at it a little differently. Again, this time you're given the length of AB. You're given the x-coordinate of A. You're given both the coordinate points for B, but your variable is that you have to find the value of y1. So again, if we look at the distance formula, AB is equal to 13. So 13 is equal to the square root of -5 minus 7 squared plus y1 minus 6 squared. You're going to square both sides to get rid of the radical. So you have 169 is equal to -12 squared, which is going to be 144, plus y minus 6 squared. I skipped quite a few steps there, so I hope you followed that. because I squared it at the same time that I squared the 13 and combined those like terms and squared that. So now I'm going to subtract the 144 from both sides, so I get 25 is equal to y minus 6 squared. Now at this point, you could FOIL that, get a quadratic, and factor it, or you can just take the square root of both sides. So the square root of 25 is plus or minus 5 is equal to y minus 6. So now I have y minus 6 is equal to plus or minus 5. That gives me y is equal to 11, and y is equal to 1. So my solution is that y1 is equal to the set 1 and 11. And you will need to do some problems like that. I think we have some practice problems in class. Graphing, we usually, up to this point, have graphed an equation by putting it in slope-intercept form. And now we're going to take a look at graphing an equation from standard form. Remember, standard form is of the form ax plus by equals c. That's standard form. So when we look at standard form, it's really easy to get the x and y intercepts. Remember, the x-intercept is when it crosses the x-axis. The value of y when a curve crosses the x-axis is 0. So we're going to say let y equal 0. When that happens, we have 3x minus that 4 times 0, which is 0, which gives me an x equal to 4 and gives me an ordered pair of 4, 0. So I have the x-axis or the x-intercept at 4, 0. Remember, the value of x when it crosses the y-axis or the y-intercept, x will be 0, so we're going to say let x equal 0. When we substitute that in, 3 times 0 minus 4y is equal to 12. So y is equal to negative 3. I have the order pair 0, negative 3. I can plot that point, and then I can graph the equation of that line. And that's about it for the video for section 3.1. It is just on those few things: distance, midpoint, and then graphing the equation of a line in standard form. I'll be doing the next video shortly, and I'll see you Monday. Thank you for listening.